Introduction to GARs in NestJS. Welcome to today's lecture on GARs in NestJS. We're going to explore what GARs are, how they function, and why they are an essential part of building secure applications with NestJS. To begin with, GARs are special classes in NestJS, and they are annotated with the injectable decorator. And they implement the can activate interface and are primarily used for authorization purposes. So this means they determine whether a specific request should be allowed to proceed based on certain conditions, such as permissions, roles, access control list, also known as ACLs. So GARs help us control access to different parts of our application by checking the necessary permissions at runtime. Key characteristics of GARs. First, GARs are designed to focus on authorization. They control access to routes based on user permissions, ensuring that only authorized users can access specific endpoints. Second, GARs have access to the execution context. This is significant advantage over traditional middleware because it allows GARs to know precisely which handler will execute next, so giving them more contextual information to make authorization decisions. Lastly, GARs are declarative in nature. This means they allow us to interpose processing logic at the right point in the request response cycle in a declarative manner, promoting the dry principle in our codebase. In case you're unfamiliar with dry stands for don't repeat yourself, which is a key concept in software development aiming to reduce repetition of code. GARs in the request lifecycle. So in order to understand where GARs fit into the request lifecycle, it's important to know their execution order. GARs are executed after all middleware, but before any interceptors or pipes. This specific positioning allows GARs to effectively manage authorization right before the request is processed further. This makes GARs a powerful tool for ensuring that only authorized requests are allowed to proceed. Creating a simple auth GAR. So let's look at how we can create a simple auth GAR in NestJS. So here is an example of a basic authorization GAR. In this example, we are implementing can activate, and we have can activate method, which returns a Boolean, promise, or observable. If it returns true, the request is allowed to proceed. Otherwise, it is denied. So the execution context parameter provides access to the current execution state, allowing us to get the request object and perform validation logic. Moving on, we're going to look into role-based authentication guard. So here is a basic implementation of roles guard, and this guard permits access based on user roles. So the guard in this example simply allows all requests to proceed by returning true in all cases. So if you want to implement more advanced functionality, you would make modification here. Attaching guards to controllers and methods. So guards can be applied at various levels in your application. Controller scoped, method scoped, or globally scoped. Here is an example of a controller scoped guard. So in this example, the roles guard is applied to the entire CATS controller, meaning it will affect all methods within this controller. If we want to apply a guard to a specific method only, we can do so like this. You can see use guard is located right above create. Lastly, in order to set up a global guard, you can use this following code. So we are using use global guards of the Nest application instance. And by doing this, the roles guard will be applied to every controller and route handler in the application. Enhancing the roles guard. In order to make our roles guard more intelligent, you can consider the roles required by each route and the roles of the current user. So this is where custom metadata comes into play. So NestJS kind of provides the ability to attach custom metadata to route handler through either decorators created via reflector create decorator static method or the built-in set metadata decorator. So yeah. Complete roles guard with role check. If we are to complete the roles guard by adding logic to check the roles, you can see that we're using the reflector in NestJS core to access the roles metadata that is attached to the handler here, and the match roles, this method here, then compares the user's roles to the allowed roles and return true if there is a match. So this way, we ensure that only users with the appropriate roles can access the route. Handling insufficient privilege. So when a user with insufficient privileges makes a request, NestJS automatically returns a 403 forbidden response. So this is what the response looked like. And if you want to customize the error response, you can throw specific exceptions within your guard. For instance, we can throw new unauthorized exception, which means any exception thrown by a guard will be handled by the exception layer, including the global exceptions filter and any filters applied to the current context. Conclusion. In conclusion, guards in NestJS are a powerful mechanism for implementing authorization logic in your application, and guards provide fine-grained control over route access, leveraging the execution context and custom metadata to make authorization decisions. By using guards, you can enhance both the security and maintainability of your application. Thank you everyone for listening.